Modernity's foundations have stood for decades. Physics has stood the test of time, like a cathedral, sophisticated, intricate, and apparently immovable. We thought we were aware of the rules, how galaxies form, how stars ignite the organization of matter in a universe governed by chaos and time, gravity and space. We instructed these principles in classrooms. We programmed satellites in their midst. We even used them to predict the fate of our universe. But when the James Webb Space Telescope pointed its ultra-sensitive eye into the most ancient region of the universe, it didn't find any proof. It failed to locate comfort. It discovered an incongruity so enormous, so evident, and so hard to deny that the very formulas we've relied on for more than a century now tremble at their edges. What Webb saw wasn't just strange, it was impractical. One galaxy brimming with established stars, huge in scale and completely organized, sat calmly during a time when, as far as we know, nothing like that could yet exist. And it wasn't alone. Webb kept showing more dot with every new image. The scientific community felt as if it were waking up in an alternate universe. Small anomalies were no longer the focus. This is about the sudden collapse of the physics we once thought would last forever. Because what James Webb has just detected doesn't rewrite the laws of the cosmos, it crumbles them. It wasn't the James Webb Space Telescope's purpose to casually look around. It was built like a time machine, crafted to unravel the universe's many layers and let us peer into the very beginnings of existence. When it turned toward a seemingly uninteresting section of space, it discovered something odd, a dazzling light source that stood out like a beacon during a storm. At first, astronomers believed it had to be relatively close, considering how strongly it glowed. But the redshift the light being stretched by the expansion of the universe told a completely different story. This object, just called CEERS 93316, wasn't nearby at all. It was positioned at a redshift of 16.7, which places it just 230 million years after the Big Bang, a blink after the cosmic clock began ticking. Nevertheless, this galaxy was not a sporadic, fragmented cloud of primordial dust. It was enormous, with stars already fully formed and organized in complex structures. Put another way, it had developed far beyond its mere existence. That is comparable to spotting an adult human in a newborn's crib. It simply ought not to be possible. However, Webb's discoveries were far from finished. When astronomers zoomed in deeper, they found more of these anomalies, complete clusters of massive galaxies that shine brightly in defiance of every formation model we've ever trusted. Either the physics of the early universe is incorrect, or we're witnessing something never seen before, the fingerprints of a cosmic process we cannot yet articulate. After the initial shock had subsided, scientists began carrying out their research. They calculated the mass of these ancient galaxies, estimating the quantity of dark matter, dust, and gas that would have needed to collapse so quickly to fulfill what Webb observed. The numbers were mind-boggling. It appeared as though some of these early galaxies had the same mass as the Milky Way, but formed just a couple 100 million years after the Big Bang. For comparison, the Milky Way took over 13 billion years to reach its current state, according to conventional cosmology. In the first few 100 million years, matter had not even sufficiently subsided to form stable structures. The cosmic microwave background, the Big Bang's remaining heat, was still bathing the universe in a cloud of radiation that should have made it nearly impossible to form stars. And yet, here we are, staring at elegant structures that resemble galaxies in the modern universe. Several of them had already exhausted their star-making gas completely, meaning they had burned through their fuel in an intense, brief burst of activity, leaving modern models of how galaxies form gasping to catch up. To make matters worse, these galaxies appear to be in clusters, implying that they are not isolated miracles, but part of a comprehensive ecosystem of impossible quantity. Our timetable is either wrong, or a mechanism is operating at cosmic scales that we've completely overlooked. In both cases, the repercussions are devastating. We do not understand how the universe builds itself. And that means everything from the Big Bang to our models of dark. Matter may need to be dismantled and rebuilt from the ground up. The James Webb Telescope does not merely reveal distant objects. It reveals the boundaries of perception itself. There are galaxies so far away that they ought to be hidden beyond the Hubble horizon. Beyond the theoretical limit whose light has not yet reached us since the beginning of the universe, and yet we see them. This brings about a paradox so uncomfortable that many scientists are attempting to completely avoid it. The light from these galaxies should not be visible. That leads to one conclusion: our understanding of space-time. Sin. Very fabric of the universe is insufficient. As the universe expands, so does the Hubble horizon. New galaxies become visible as a result. However, Webb isn't seeing galaxies that have just crossed the horizon. It's seeing galaxies that were never supposed to be there at all at distances that suggest either a faster than anticipated rate of cosmic structure formation, or worse, that the geometry of space itself could be bending in ways our equations cannot model. Think of it like trying to look at the margins of a painting that's growing faster than your eyes can keep up with. You are not simply seeing something from the past. You are seeing something that cannot be. And that impossibility is speaking back in the language of shattered symmetry, disrupted causality, and broken models. James Webb is no longer just a telescope. It's a test of character. One that is now telling us, you were wrong about the universe's regulations. And the universe has only just begun to explain with each new image, each confirmed redshift, and each unexpected signal interpreted. The cracks get wider. The Big Bang theory, the cornerstone of modern cosmology, begins to resemble a patchwork rather than a masterwork. Scientists have begun suggesting alternatives, from cyclic models of the universe to radical ideas like emergent spacetime and quantum cosmogenesis. Some theorists believe we might be seeing the glow of an earlier universe bleeding into ours. Others suggest we are misinterpreting the structure of time itself, that time did not begin at the Big Bang, but emerged later, a byproduct of entropy, not a cause of it. Even more daring voices are whispering what was once heresy, that it might not be redshift, nor distance, nor time measurement at all. That light might act differently in deep time, or that physical constants have changed as the universe evolved. Each of these concepts has one thing in common: they discard everything from the current standard model, and yet they are no longer fringe, because James Webb has now revealed more inconsistencies than confirmations. The scientific community is under immense pressure to face the unimaginable, that the Big Bang, as we taught and understood it, may be at best an approximation, or at worst, a beautiful lie for decades. Dark matter has been the invisible framework upon which all our cosmic structures were constructed. It's invisible, unable to be seen by light. And yet, it was always assumed to be their baffling substance that makes up nearly 85% of the material in the universe, silently guiding the formation of galaxies like a hidden architect. But the James Webb Telescope's early images are interfering with that framework. The galaxies it is observing, those ancient, massive structured clusters, appear to be forming and advancing at rates that would necessitate more dark matter than current models allow. In fact, some of them would require densities of dark matter so extreme that they should have collapsed into black holes beneath their own weight. Others appear to be forming in regions where dark matter should not be dense enough to allow this level of gravitational binding, at least not this soon. This is not simply a mathematical error. It is a fundamental contradiction. Matters are acting differently in the beginning of the universe's density and distribution, then defy our simulations. The underlying physics of dark matter could have fundamental flaws. Worse, nonetheless, it could indicate that dark matter isn't even remotely real. Or that what we're calling dark matter is something completely distinct, placeholder for a property or force we haven't even conceived yet. Also, if this is true, then the universe's structure could be guided by principles to which quantum mechanics is as foreign as it ever was. Newton once said, one of the most frightening consequences of the discoveries made by the Webb is that time, the most anticipated and warranted aspect of our universe, might not be all-encompassing. The galaxies are not just seen on the Webb as excessively large or bright, they appear to change more quickly. In some situations, their stellar populations appear older than the universe itself was at that moment in the past. That is not simply a red flag. It sounds a cosmic alarm. If time moves in different ways under some conditions, say under extreme density or in areas where quantum fields change violently, then eventually the entire concept of cosmic time becomes shaky. This makes radical models possible, including light's varying speed theories of altered gravity, the possibility that time itself is emergent, not a fundamental dimension, but a statistical gimmick created by observation and entropy. Assume that time is not a river, but instead a fog varying in thickness from moment to moment, occasionally spinning backwards around a gravitational drain. The James Webb images may be snapshots of a universe where time hasn't behaved consistently, where the location of causality is tangled, and in areas where evolution fails to continue in the same direction. In that case, not only are our equations out of date, they are written in an entirely incorrect language. Anomalies extend beyond galaxies. James Webb has found population 3 stars or something frighteningly similar to them. These are intended to be the absolute first stars to ever appear. Massive, fiery behemoths made without metal, formed from primordial hydrogen and helium, theoretically. They lived quickly, died young, and broke apart in supernova that seeded the universe with the heavier elements required for life. The problem: we've never actually seen one. Not yet, or perhaps not completely. The stars the Webb is detecting don't follow any known stellar life cycle. They are too big, too hot, and contain too little metal for their time yet. They exist somehow. It's as if nature found a way to skip forward in evolution, producing stars that violate the known nuclear processes of fusion. A number of astrophysicists are quietly speculating that these could be evidence of pre-stellar collapse, events, possibly even black holes, that failed to ignite in ways we've never seen before. If confirmed, these stars would be more than exotic. They would redefine nucleosynthesis, challenge our models of stellar extinction, and pose a question that even the boldest physicists find uncomfortable. Are there forms of matter and energy at play in this situation that we have no language for yet? Music as if gravitational, structural, and temporal anomalies weren't enough. Some deep field images taken by James Webb suggest an additional unsettling concept: repetition and patterns. Clusters, symmetry, structural distributions, alignments. 7. Galactic spin stretch across billions of light years. These patterns defy random chance and are statistically significant enough to merit serious consideration. However, this is where it gets truly strange. These alignments suggest a universe with a large-scale structure that isn't just chaotic expansion, but possibly engineered. The notion that the universe could have an inherent order beyond what inflation and gravity can account for is now being whispered among theorists, some of whom were once die-hard materialists. A few invoke simulation theory, claiming that the universe could be a generated structure, a cosmic rendering driven by unknown variables. Others revisit ancient mysticism to quantum consciousness, trying to determine whether the universe has a substrate for information that not only recalls, but may also respond. And the more you look into the Webb, the more it feels like the universe isn't just observed, is now looking back. Therefore, here we are, following billions of dollars in engineering and decades of theoretical groundwork. The opening of the James Webb Space Telescope became a doorway only into space, but into the very essence of science itself. And what it revealed was not comforting. It wasn't confirmation, it was chaos. Elegant, structured chaos that contradicts nearly everything we thought we knew. Galaxies that should not exist, stars that should not form distances that should not be observable, a timeline that appears more like a jumbled dream than a linear path. The foundations of physics haven't been refined. They've been shattered. And when the dust clears, we are left with a haunting inquiry. Suppose we've been asking the wrong questions all along. What if the answers aren't hidden in equations, but in the gaps between them, in the places where logic fails and mystery begins? Because perhaps, just perhaps, the universe was never meant to be merely witnessed and understood. Now it is observing us. If this video stirred something inside you, a question, a wonder, a fear, don't let it go. Subscribe. Because what James Webb is showing us is only the beginning. If your perception of reality shifted, even just a little, leave a comment below. How do you feel about it? What is the universe trying to tell us? Well, be reading every word, because now more than ever, it's not just about watching the stars.